And now let's us finish up these 8-1 law of sines notes. So example 5, a point P on level ground is 3 kilometers due north of point Q. So if here's my point Q, then 3 miles due north, here's point P. A runner proceeds in the direction of north 25 degrees east from point Q to point R. So remember that north 25 degrees east has to come off of that north-south manner. So we're going to go north 25 degrees east. So this is our 25 degrees. And up here is my point R somewhere. And then from point R to point B in the direction of south 70 degrees west. So we're going back in this direction. But it's not this interior angle. Remember that 70 degrees is off of the north-south. So this full angle is going to be my 70 degrees. So we have our figure, and we need to approximate the distance of the run. So keep in mind the runner ran from point Q to point R, so this is side P, and then they ran from R to P, which this is side Q. So this 3 miles was not part of that runner's run. We ultimately need to find the distance of P plus Q. So we need to figure out what that interior angle is. So I want you to take a look at if I have 2 parallel lines, and if we cut them by this transversal, then hopefully you recognize that alternate interior angles. So this 25-degree angle, and this is going to be a 25-degree angle by alternate interior angles. So therefore, if this is a 25-degree angle and the whole thing is a 70-degree angle, then this interior angle here is going to be 45 degrees. And so now, using the idea that the sum of all the angles in a triangle is 180 degrees, 180 minus 25 minus 45 gives me a 110 degree angle. So this angle over here is 110 degrees. And now I should be able to use the law of sines because I know this side and I also know the angle opposite, and I know this angle and I can find that side opposite. So I could say that Q over the sine of 25 is equal to 3 over the sine of 45. So I would like you to pause the video and solve that. You should get that Q is 1.79 miles long. And then I can similarly, I need to find side P, and the angle opposite side P is the 110, so P over the sine of 110 degrees. Again, we want to use the given information as much as possible, so 3 over the sine of 45 degrees. And when you put all this into your handy-dandy calculator, you should find that P is 3.98 miles. So the total distance of the run, 3.98 miles plus 1.79 miles, means she ran a little over 5 3/4 miles, 5.77 miles. And now example 6. A commercial fishing boat uses sonar equipment to detect a school of fish 2 miles east of the boat, traveling in a direction north 51 degrees west at a rate of 8 miles an hour. So what do we have here? We have our boat, and 3 miles east of the boat, we have our fish. The fish are traveling north 51 degrees west. So again, off of that vertical, they're going north 51 degrees west. So this is my 51 degree angle. And we need to find out if the boat travels 20 miles an hour, approximate the direction it should head to intercept the fish. So we want to intersect the fish, and we need to find that angle measure. So I'm going to call this angle beta. And because this is off of the vertical and this was directly east, this total angle is 90 degrees. So 90 minus that 51 degree angle means that this interior angle here is a 39 degree angle. And so now I can set up, I have the sine of beta over this side B equals the sine of 39 over, I'm going to call, because I labeled that fish, I'm going to call that side F. Well, I'm trying to find, the question's asking me what this angle B is, so I'm going to solve this for the sine of beta. Multiplying both sides by B, I could write this as B over F times the sine of 39 degrees. But now I've got a problem because I have three variables. I have the sine of beta, I have B, and I have F. But they gave us a little bit more information, and we know that distance equals rate times time. So we know that F, the fishing boat, is moving at a rate of 20 miles per hour times however long it's going to take them. Whoops, and so that's the boat is going that side F, and my fish is going this side B. They're going 8 miles per hour, so 8 times the miles per hour. So now I just need this ratio of B over F. So 8t over 20t, my t's cancel, and this simplifies to 2/5. So now I can come back over to this example, or this problem, and I have the sine of beta equals 2/5 the sine of 39 degrees. So when I plug that into my calculator, I'm going to find that the sine of beta equals 0.2517. And if I take the inverse sine of that, I find that beta is 14.6 degrees. So this angle is 14.6 degrees. But I need to know the heading that they need to take. So remember, your heading is off of that vertical. So I need to figure out what this heading is. Again, it's off of 90 degrees. So 90 minus 14.6 gives us 75.4. And from here, he's going north and he's going east. So it's going to be north 75.4 degrees east is going to be the heading that he needs to take. And the last question, find to the nearest minute the time it will take the boat to reach the fish. Well, I know that the boat is traveling at a rate of 20 miles per hour. I just need to find out what that distance is, and then I can solve that for t. So 180 minus 14.6, that interior angle, minus the 39 equals 126.4. So this angle up here is 126.4. So now I can solve this for f by taking f over the sine of 39 degrees equals 3 over the sine of 126.4 degrees. And it's a good thing that up here in all this work I have not yet used this distance, because this distance is actually 2 miles. So that should actually be a 2. I apologize for my error. When I multiply both sides by the sine of 39 and I solve this, I should get that f is 1.56. So 1.56 equals 20t. I can solve this for t. Divide by 20, I get 0.078. Keep in mind this is hours, so to find that in terms of minutes, I need to multiply this by 60 minutes in an hour, and I get that this is about 4.68, so it takes him about 5 minutes to intersect that school of fish. If you have any questions with these two examples or any of the previous examples I've done for the law of sines, I look forward to seeing you in class.